Hello and welcome back to Gen Chem with Dr. J. I'm Dr. Janita Pritchett, and on this channel we cover all things Gen Chem related. On this video, I'll be covering different types of electromagnetic radiation, and we'll learn how you can compare amongst the entire spectrum. Let's get started. So in the previous video, you learned how to go about calculating the wavelength, or the distance between the different peaks that are found within a different type of light, as well as the frequency associated with that light wave. Well, if you think about it, the colors that we observe, they represent a form of light that we can determine based off of its wavelength. Now, colors, or really even its frequency. Now, if we think about the white lights, if we think about what white light is, we know that it is a mixture of all the colors of the visible spectrum, including red, orange, yellow, green, blue, or violet. And so each of these different colors would have their own associated wavelength affiliated with them. Based on if they're kind of a warmer color or a cooler color, we can think about the relative order that they would be in the entire spectrum of electromagnetic radiation. Now, the colors that we observe are based on when white light hits an object. Some of the colors are absorbed by the material that we're looking at, while others are reflected. Those colors that are reflected, like the picture that's shown here where the red light is being reflected, are what we're ultimately observing. And again, if we think back to those terms that we learned before of our amplitude and our wavelength, well, when it comes to the wavelength, our warmer colors tend to have longer wavelengths. So your reds, your oranges will have a longer distance between the peaks found in the waves compared to your blues or violets or even your greens. And so again, we could think about, well, if they have longer wavelengths, that would mean that they would have shorter frequencies or lower frequencies. And if they have shorter wavelengths, they would have higher frequencies. And that's going to be important when we think about ordering these things in a few minutes. Also, the amplitude, or again, the height of those waves will dictate some of the different colors that we're able to observe from these colors. So with the electromagnetic spectrum, it's important to remember that the visible light that we observe and that we see often, it only represents a very small fraction of all the different types of wavelengths that exist. So the different lights, when placed in order, are what we know as known as the electromagnetic spectrum. And so something that has a short wavelength or high frequency would also be considered a high energy subject. And so remember, there is that inverse relationship between your frequency and your wavelength. And so we're saying here, if you have a shorter wavelength, you would have a higher frequency and subsequently also a higher energy associated with your type of light. And so your lowest energy type of electromagnetic radiation is radio waves. Your highest energy would be your gamma rays. Now, those high energy items, those are things that we want to avoid. Those are things that can be very damaging when it comes to biological molecules. And you'll see certain types of waves that we're going to talk about, like UV rays, are on that higher end. And we can actually see this high energy damaging effect in real time if you've ever gotten sunburn or something like that associated with your skin and interacting with the sun. And so there are a large array of different types of electromagnetic radiation that exist, and so they're listed for you here. Again, your lowest energy ones are your radio waves, and so those are ones that aren't as damaging to biological substances, and we can stand to be around them more readily. You then next have microwaves, which come after that, and then infrared waves or rays, and there's several subsections that are found there. There's visible light, which includes your colors, your Roy G. Biv. And then you have ultraviolet. Now, this is where we start getting in that damaging region. We also would have X-rays. Think about this whenever you go to the dentist, they often will put that protective shield on you if you're getting an X-ray done, and that's to prevent damage to any of your other body parts. And then, of course, there are gamma rays, which would be our lowest, smallest, shortest frequency, shortest wavelength, highest frequency, highest energy thing. And so you'll want to be able to think about these in a number of different ways. You can think of it from the frequency standpoint. You could think of it from the energy standpoint, or even the wavelength. So again, here, these are our larger wavelengths, or the longer wavelengths. These are our shorter wavelengths. Or similarly, you you could say from top to bottom, those are your low frequency and low energy items to your high frequency, high energy items. And so when you look at the overall electromagnetic spectrum, you can see that indeed that visible light really does represent a much smaller portion, only a fraction of the entire electromagnetic spectrum. And so this will be a good reference slide for you if you are having to do any type of comparison of the different types of light that exist and need a quick reference. So let's do just that. We're going to practice putting these in order. Our microwaves, gamma rays, green light, red light, and ultraviolet. And the first thing we want to do is we want to classify them in order from short to long wavelength. So in this case, our shortest wavelength would be our gamma rays. Remember, short wavelengths are those things that have high energy. And so that would be our gamma rays, followed by our UV light. And then next, well, it would come to the colors. And remember that your cooler colors tend to have shorter wavelengths, so green, followed by your warmer colors, red. And then last but not least, the microwaves. Now, if we wanted to take this same list and classify it by frequency from low to high, well, again, low frequency things, those are things that aren't as damaging to us, the biological substances. And so out of this list, we would say that it would be microwave, followed by red, followed by green, or what you'll notice is the exact opposite of the list that we had above, followed by UV, and then followed by your gamma rays. And then last but not least, by energy from least to most, well, if we're going from least to most energy, it should be the exact same list that we see above from low to high frequency. So again, it would be microwaves followed by red, then green, then UV, and then gamma rays. Okay. So I hope this video helped you understand about the different types of electromagnetic radiations that exist and how to actually order them. You can use this as a great reference as you move into different parts of this chapter and other parts of chemistry as you are thinking about the electromagnetic spectrum. Be sure to like, comment, and subscribe, and let me know any new content you would like to see. See you guys in future videos. Have a great day. Bye-bye.